This experiment is entitled Voltage Current Ohms Law. When you have completed this exercise, you will be able to measure circuit voltages and currents and demonstrate Ohm's law using measurement of the circuit parameters. The equipment that would be used is a lab volt. This equipment will be used in order to measure and explain the different circuit characteristics of the elements, which are the power, voltage, resistance, and current that can be measured through the computer. The devices that will be used in the experiment will be the power supply. The power supply will be used to energize the circuit from 0 to 120 volts. This terminal of the power supply is at the terminal 7N. This will allow us to control the voltage from 0 to 100% of the capacity of the supply voltage. This will also supply the 24 voltage that is needed by our data acquisition and control interface. The next device that would be used in our experiment is a data acquisition and control interface, or your DAI. This will serve as the measuring system of the circuit. It is powered by a 24-volt DC supply that is connected in the power supply. The DAI is composed of a voltmeter, which is connected in parallel with the load, and an ammeter, which is connected in series with the load. Our DAI also serve as a protective device of the circuit because of the fuse connected in the ammeter. That is why connecting every connection to the DAI will protect the performers from apparent short circuits due to wrong connections. The next device will be our resistive load. The resistive load consists of a module housing 9-wire wound power resistors arranged in 3 identical banks. Each bank consists of 3 resistors connected in parallel that can be switched on or off with toggle switches to obtain various resistance values. This allows the total equivalent resistance of each bank to be increased or decreased by steps. 6 safety banana jacks on the module front panel provide access to each resistor bank. The resistors banks can be connected separately for operation in 3-phase circuits. Also, the 3 resistor banks can be connected together for operation in single-phase circuits. The resistive load is commonly used in conjunction with other basic load, like the inductive load and the capacitive load, to experiment with the effects of the different types of load on a circuit. In the first part of our experiment, we would measure the resistance of our voltmeter and our ammeter from our data acquisition and control interface. Take note that in measuring the resistance of this ammeter and voltmeter, we would use our ohmmeter or the multimeter from our digital or analog multimeters. So take note that when you are measuring the resistances, take note that there should be no power in the system, and the range or the classification of your meter should be in resistance mode. The volt is the measurement unit of potential difference, and voltage is measured with a voltmeter. Voltmeters are always connected in parallel with the circuit or component. They have a high internal resistance to minimize the amount of circuit current that will flow into their terminals. Their effect on the circuit operation is then minimal. Note that the polarities marked on the standard analog meter terminals must be observed to obtain the positive reading. If the connections are reversed, the reading will be negative. Let's now measure the resistance of the ammeter of our DAA. The ampere is the unit of measure for electric current flow, and current is measured with an ammeter. Ammeters are always connected in series with the circuit. They have low internal resistance to minimize the addition of extra resistance to the circuit. Polarities must also be observed when connecting an analog ammeter to ensure that the pointer deflects in the proper direction. So we will now measure the voltage and current in a circuit using your DIA or your data acquisition and control interface. Take note that this circuit is an ordinary series circuit wherein R1 is in series with our source, which is your ES. Take note that this is a variable DC source. Since you would want to measure the voltage of R1, we would parallel our voltmeter and our ammeter will be connected into the circuit. Our R1 will be equal to 171 ohms, which is the parallel combination of the 600 ohm, 300 ohm, and 1200 ohm in a branch of the resistors. So as you can see in our video, I connected our power for our data acquisition, which is 24 volts and 3 ampere. It should be used in order for our data acquisition to be functional in gathering the data that we need. So after this, I base my connection to our circuit diagram. Okay, so as you can see, the circuit diagram is a simple series circuit of the combination of 600, 700, 600, 300, and 1200 ohm in parallel to the source. So I turned the knob into 7N. So 7N is a variable DC source from 0 to 120 volts. So first thing I did is that I use the ammeter in series with our source. So from 7N to the positive terminal of our ammeter, and then from the negative terminal of our ammeter to our load. And then I completed the circuit in order to make it a closed loop from our load to the neutral of the source. So the line to neutral voltage of our source is 120 volts. And then I would want to measure the voltage of our resistor. So I may use shorter wire and directly connect some of its terminal to the terminal of our ammeter, but I choose to demonstrate the connection of our voltmeter that it is connected in parallel with the element that they want to measure. So this is the circuit connection. And then, based on our circuit diagram or in our experiment, the amount of resistance that is needed is equal to 171 ohms, which is the parallel combination of your 600 ohms, 300 ohms, and 1200 ohms. After setting up the circuit, let us display the metering application and select Setup Configuration File ES11-1 DAI. Note that the metering setup configuration files are not essential for completion of the exercise. They are intended as a starting point and can be changed at any time during the exercise. Turn on the main power supply and set the 24 volts AC power switch to the on position. Adjust the main output control knob on the power supply to obtain a series of voltage from 0 to 100%. Turn off the power supply after the last data acquisition. Verify that the measured values have been stored in a data table. And then, click the graph button to display the graph window and make the following selections. Like let y-axis be your I1 and x-axis be your E1. In the graph window, make sure that the line graph format and the linear scale are selected. A graphical plot of the data should be displayed in the graph window. So this will be the graph that is formed from our I1 and E1, wherein I1 is the current and E1 is the voltage, and I1 is at y direction and your E1 is at x direction or your x-axis. So after tabulating the values, let us change the value of the resistance to the value given in the following table, wherein the value that we did at 120 volts is 200 ohms. Take note that 200 ohms is the parallel combination of your 300 ohms and 600 ohms. So, ang gagawin natin, ibababa lang natin yung 1,200 ohm. And then, use the record data button to store the voltage measurement in the data table and then turn off the power supply. So, we will now set our load into 200 ohms wherein your 600 ohms is in parallel with your 300 ohms. So, ibababa natin yung 1,200 ohms. And then after that, we would energize the circuit. And then, we would not put the knob into 100%, but into the 120 volts only, in order to check whether the current will be equal to 0.6 ohm, which must be appropriate as the reading of our ammeter.